System equation was you're finding the intersection of two lines, you're trying to find the point at which they intersect. And you did linear combination, substitutions, all that kind of stuff. Well, guess what you can do? The same thing with conics. So we can find the intersection of a hyperbola and an ellipse. We can find the intersection of a parabola and a circle. We can find, this is an awesome one, this is a great one. Let's say you have your hyperbola, and what if your ellipse was doing that?
That's so pretty.
Thanks.
Wow.
It looks like that art show, like there's all different colors and then they're all like.
Well,
It's got teeth. Ooh, it looks like a parrot, right?
What is that? That looks like a parrot butterfly. What is that?
I don't know, that looks awesome. It's got a tail.
See what you're
What?
Calm down, Emma. Oh my gosh.
I got it. So let's forget all that now. What can be never unseen? Let's find the intersection of what looks like a circle and a line.
plug in Y.
Pretty much. But we're not doing electrical work. We're not plugging in something to an outlet. No. Graphing these things is so highly overrated. Graphing these things is extraordinarily inefficient to do this. Algebra is your friend. Algebra will tuck you in at night. Algebra will keep you warm on a cold evening. Algebra will always love you.
But it's a concept.
Algebra will always help you find your x. So you got two equations. I know. What am I going to use? Substitution. I'm going to use substitution.
That's what I said.
You said plug it in.
I meant plug it.
I'm not plugging anything into an outlet. Am I taking this and going, oh, we're plugging this in an outlet? Nope.
That is what Mr. Loftus said to call it. Plug it into an equation.
So you get x squared plus the quantity x plus 1 squared equals 13. Ladies and gentlemen, what are you going to screw up here?
Distributed property.
You are going to screw up the distributive property. Please do not kill the puppies. Please. Please, please, please. Foil. Foil it out. Don't kill puppies. Puppies are nice. Puppies are healthy. Puppies make you smile. Okay. And then you never mind. Hey, look, we're back to a quadratic. If you're trying to find a zero, what's the first rule for finding zeros? Not cry, but is? What's the GCF? You can take it out, buy it dinner?
Yes.
Nice. So take out the 2.
Oh, I get it.
Remember, the jokes don't get any better throughout the year. Does
Not,
that 2 what's that?
do you not practice your jokes?
No.
We had a student teacher last year who practiced her jokes.
Really? Who was this for what class?
Miss Ogrevon?
Oh my gosh,
Humanities.
humanities. She's like, I would go home at night and I would like say the jokes like in my head. So I had like,
Oh, are you kidding me? I'm winging it.
they're not like bad. They're just like
They're just not.
We're gonna learn about
sure if it's serious.
You doing PJ Fry's meme?
Who?
PJ Fry's, that's
I
who that
don't-
is.
I don't even know who. I don't know. I don't know.
The not sure thing with it's like the guy squinting.
Oh, no, I honestly don't know what that is.
That's
The
Futurama.
Swedish Chef is funny.
Oh, I remember that show.
I don't even watch that show. I know who that is.
Okay. Just do you have any problem with any bearing on the problem anymore? No. What times what's -6? You add together to get 1. One of the other reasons why I'm showing you guys this, because as we get into the polynomial operations next chapter, is that we talk a ton about terms, in parentheses, and zeros, the solutions. We're going to have a lot of references back between terms and zeros. It's a huge, huge thing,
You
okay?
don't need to leave, you don't need to keep the 2 though?
No. It's a constant. When you have GCF, it doesn't have a problem. It doesn't have anything to it. Now, if it was a 2x, then I'd have to set that equal to 0 as well. But since it's just a constant value of 2, it doesn't matter. Okay. So now I have zeros at 3 and 2 for x, which means I got to figure out my y values. So we take these values here and substitute back there. This means that you're going to have 2 ordered pairs that are going to intersect the circle with the line. You'll have one at an x value of 3 and one at an x value of 2. All I have to do then is just solve them for y. So what's -3 plus 1?
-2,
And what's 2 plus 1?
3.
That's the solution to this set. Those 2 points are where they intersect. That's how this works. It's just a lot of substitution and going through. One of the big suggestions that I would give you guys, it's not that you're looking for just the 1, 0. We're actually, or looking for one set of ordered pairs. We could be looking for multiple sets of ordered pairs. Okay. You could get up to 4 of them if you think about it. We start looking at all the different conic sections. You could get, like that one awesome picture that was just really, really ugly. If I had an ellipse running into a hyperbola, it could hit it in 4 spots. You know, if you had a parabola and an ellipse, it could be 3 spots, 4 spots. So there's multiple values that could work together. All right, you get a lot of plus minuses sometimes, so it's just algebra. Yay! What's up, Jack?
Yeah, but how'd you get to the bottom? Where you got just, oh wait, this one is, it's,
Couldn't you do 3,
No, because x is 3. You're solving for x here. So x is 2, y is 3.
where you get -2?
Where do I get -2? What's -3 plus 1?
And then like, but how did you get 2 points?
Because I had 2 values of x. If you think about this, this is the circle, and the line's going through the circle, and it's touching at 2 ordered pairs. The ordered pairs are at -3, -2, and 2 and 2. That's what it's doing.
So you keep the -3.
Yeah, that's the x. Hey, this looks like fun.
Yes.
Can we set them equal to each other with minorities and
You're not going to be able to get, you won't be able to get your, you cancel stuff out that way. You start thinking about it. Sometimes that's one way that things get eliminated. And it's not the cleanest method to do that. And when you start with these, again, it's just a matter of picking one and going for it. So, if you look at what we have, we need to make a decision as far as which one do we want to get by itself. Well, in the top equation, I have an x squared, a 4x, or it's x squared and a y squared. If I got y squared by itself in the bottom equation, then I'd have y squared is going to be equal to some, like with an x, but it looks like I'd also have to deal with some fractions. It could work, but it could get ugly.
equals on the 2y squared minus.
And that's what I was gonna get at. What I'm looking at here is that since I have a single degree value of x to the first power in the bottom equation, if I get that value by itself, it's generally easier to put that in, or get that by itself and then substitute back in to a squared term, because then all I do is FOIL. If you go through and you work with an x squared and try to turn that into an x, you have to have square roots, plus minuses, and it gets really, really, really ugly. So anytime you've got just a single value and everything else is squared, try to get that singular value by itself. And what I mean by singular value, it's got a degree of 1, power of 1. Right? Does that make sense? So getting that second term or second setup equal to, or x by itself, we're going to get x is going to equal 2y squared minus 2. You okay with that? All right. So we take this and throw it here. So we're going to get 4y squared minus 4y minus 8y plus 4. Okay, yeah, plus 4 plus 4y minus 4 is 0. Yeah, and I didn't write that out. Yeah, let me just write it out. So you have 2y squared minus 2, 2y squared minus 2. Do you guys remember the rule when you multiply exponents? What do you guys do when you multiply the exponents? Add them together. So then we have minus 4y squared, so it becomes minus 8y squared. I forgot the power there. And then plus a 4, plus 4y minus 4 is 0. What's that? You know, I am so glad you're paying attention because that's exactly what I was making sure you were going to see. Good work. That was a good thumb and throw at the same time, though. It was an instantaneous, nice work. Put your arm down. You're right. No, what's up?
I'm sorry, how did you get the original x equals 2y? 2y squared minus 2.
I added that over and subtracted that.
Oh, okay.
Yes, ma'am.
Isn't the second 4y squared? Because it's squared in like the equation at the top.
God bless it. Murphy, stop screwing up. I know, I'm sorry. It's my first day. Please. I've worked so hard on telling you guys jokes, I forget how to do my material.
So you do practice.
No, I don't.
So it's 4y to the 4th minus 4y squared.
Well, that's going to look a lot cleaner now. Yeah, so it's 4y to the 4th minus 8y squared plus 4 plus 4y squared minus 4. This is going to be a lot easier now. These go. You get 4y to the 4th plus 4y squared is 0.
It's minus. There you
GCF, what do you get?
go. 4y squared.
You okay with that? Okay. Now that means you have two terms set equal to 0. So we have 4y squared.
Can you go back up? Yes.
And then y squared minus 1 is 0. Well, that's a difference of squares. If I solve it, I add 1, take the square root, I get plus minus 1 for my zeros there. And then the other one, what's the 0? 0. So this has three possible, this has three possible y values. 0, plus minus 1. So when this occurs, what you want to do is off to the side, remind yourself that you're going to have three ordered pairs with y values of 0, 1, and negative 1. And now instead of substituting in for x, we're going to substitute in for y. Well, if you don't screw up like I do, you'll be fine. And you have y by itself, or x by itself here, and it's just a matter of substituting in. Okay. So if I substitute in for y at 0, what's 0 squared?
0.
What's 0 times 2?
0.
What's 0 minus 2?
-2.
What's 1 squared?
1.
What's 1 times 2?
2.
What's 2 minus 2?
0.
What's -1 squared?
1.
What's 1 times 2? What's 2 minus 2?
0.
Go on your happy way.
Yeah.
And some of these can get god awful. I should show you guys one that's just, it's like a double square root. It's awful. Yes, sir?
How would you 7?
7. Oh, this is plus or minus, this is a -1. Yeah, your angle, you might not have seen it. It was a, because I had plus minus 1 here, so this was the -1. Yeah, if I wrote 7, I really goofed up somewhere. Yeah, some of these things you can get, and I should show you guys a solution to one of these, where you have to use a quadratic formula to get a 0, and then you're using something with a square root to substitute in, and then you have to use the quadratic formula again. So you can actually get double square root problem 0 intercepts. It's awesome. Am I going to give you those?
Probably.
No.
I'll just wait for the test.
No.
Wait, how do
How
you decide?
about
You
no?
can't just wait for the test to do something like that.
Why not?
We would all fail, and then
No,
it'll
you
be on
won't.
you. It'll be on you. It'll be your fault.
No.
Yeah.
Do you honestly think I'm serious?
I have
Yes,
no
you
idea.
are.
Haven't you figured this out yet?
How do you decide if we're solving correct or why?
It's just where the problems lead. It's a lot of times. This is a really good question. Why? How do you decide whether or not you're going to work with X or Y? Is that it really depends on how the problem starts. One way might be easier than another, and that's all it is. Okay. And just remember what you're solving for, so you don't accidentally put the Y's in the X column. Yes, sir.
To turn your own me back on you, not sure it's serious.
Yeah. Yeah. I quite honestly, I wouldn't do that to you guys. Maybe.
Looks like
I could give you. I doubt it. Should we do one last one? Yes. Let's do one last one.
wow. My cousin going, somebody who says
Here, I will leave you alone. You okay? you just did what I did at the you did that's what I did. The whole
It just happens.
it does, and it's okay. Hey, this is the easiest one. Look what happens. If I rewrite these things underneath each other, what can I do? The y squareds would cancel out. This is that linear combination style. Sometimes it's going to be set up where you can just kind of put them together. So if I add these two equations together, I'm going to get 2x squared minus 16x plus 30 is 0. Take 2 out. Buy it dinner. What times what's positive 15 that you have to be able to get negative 8? Very good, negative 3, negative 5. Our zeros, because our terms are x minus 3, x minus 5, our zeros are 3 and 5. We found them for x, so I have to take those values of x and put them,
Back into substitute something.
substitute something. Now, does it matter which one I use? No, it's just that one of these might be more of a pain than the other. Let's see here. Let's do this. X squared minus 9 is going to be y squared. You okay with that? But in order to get y by itself, what do we have to be able to do? Square root. But the x squared minus 9 isn't junk squared, is it? No. So let's see here. What if we try?
Add the 9 and take the square root and the x is y plus 3.
No, because then you can't factor that, because if you get x squared equals y squared plus 9, that's a non-factorable problem. Okay. But we do have x plus 3, x minus 3 is y squared. And if you look at that, and I throw in 3, what are you going to get?
6 is y squared.
It's going to be 0. Okay. It would be 0. So 3 would have to be 0. Okay. That has to be. That one's the easy one. Now, if I do the same thing with the 5, I get, what's 5 squared? 25. So I get 25 minus 9 is how much?
16.
16. So if 16 is y squared, what are the two values of y then? 4 or negative 4, which means, in this case, since it's y squared equals 16, you're going to have a 4 and a negative 4. Yes. Sometimes this might not show you that it's going to be replicated until you get to your substitution. And that's about as tricky as this gets. That's as complicated as I'm going to make this for you guys. And that's where this falls into, is that sometimes if you have, where it's not going to be, you're substituting in to get just a y by itself or an x by itself. If it's an x squared by itself, when you substitute in, you do run the possibility of having a plus minus value when you take the square root, okay? So you can't take the square root of x squared minus 9 because it's not junk squared, which means you have to substitute in your values and then work it backwards. It was easy with the first one because it became 0. The other one is, you work from there. We okay? Can you do 4 of these, you think? I think that's all I wanted to do. You might even be able to get it done before you get out of here. Yes, ma'am.
I have a question. So in Spanish, said I didn't do my 10.6 homework, so there were like 2.
Yeah, I thought you didn't have the graph stuff. I know I was going to ask
Were
you,
there
did somebody
2
else,
sections?
because I think it was all it was just the graph one. That's it right there.
Like this?
Yeah.
None of these.
Yeah, I'll fix it there, because I know you did, I was going to ask you where they were. So let's do this. This is the 10-7. It's 635, 636 in the good old OB. Let's do 32, 37, 38, 40, and 42. So I'm sorry, 5. I know, I'm a jerk.
That's almost.
I'm a jerk. I'm sorry. I'm sorry. I'm gonna get over it.
The jerkiness?
Yes.
I don't think it's something you just get over. It's like the, the saying like once a cheater, always a cheater, once a jerk, always a jerk.
Wow. I'm not that bad. So you think so? What's that? Yeah, I was actually just pulling it up right now. What did I say? It was 32? It was 32, 37, 38.
40, 42.
The first one you're not going to,
Why not?
because you got y by itself.
Oh, I thought my mind didn't see that.
Yeah, some of them you can add together sometimes. It really depends on how the problem's set up to choose the elimination method or whatnot. Okay, we'll go from there.
So then do you just start with like one of the equations?
Yep. Make a decision and roll with it. See what happens. If it doesn't start working out cleanly, then you know you didn't make the right decision. You chose poorly. Movie reference.
So like
Nobody knows the movie? Chose poorly. Dun, 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 dun.
I know.
Raider, it was Last Crusade. What'd you goof up?